Welcome to Trendsetters. Join us as we explore the future of megatrends. Imagine a world where energy is as abundant as the stars in the sky, where the sun's power is harnessed not just during the day but around the clock, and where our reliance on fossil fuels becomes a relic of the past. The genesis of space-based solar power. The concept of space-based solar power is rooted in humanity's enduring fascination with the cosmos and its potential to solve earthly problems. While the idea first appeared in Isaac Asimov's 1941 short story Reason, the notion of collecting solar power from space gained scientific traction during the 1960s. It was during the height of the space race that researchers began exploring practical applications for harvesting energy in space. By the 1970s, NASA and the U.S. Department of Energy conducted early studies that identified the technical feasibility of space-based solar power, though the high costs of space exploration at the time hindered progress. Today, thanks to advancements in materials science, robotics, and satellite technology, this once speculative idea has moved to the forefront of renewable energy research. Countries like Japan, the U.S., and China have announced ambitious plans to develop space-based solar power systems within the next decade, signaling a paradigm shift in energy generation. These developments echo Asimov's prescient vision, underscoring how science fiction often lays the groundwork for real-world innovation. Why space? The advantages over terrestrial solar power. Ground-based solar power has been a cornerstone of renewable energy, but it has its limitations. Weather variability, seasonal changes, and the day-night cycle mean terrestrial solar panels can only operate efficiently during specific times. Space-based solar collectors, however, are free from these constraints. Situated in geostationary orbit or other advantageous positions in space, they receive uninterrupted sunlight, even when it's nighttime on Earth. This unique positioning allows space-based solar power systems to generate up to 13 times more energy than their ground-based counterparts. Additionally, these systems bypass atmospheric interference, including weather phenomena like clouds or dust storms, which reduce the efficiency of terrestrial panels. By delivering energy directly to Earth, space-based solar power could become a cornerstone of global energy infrastructure, offering a reliable and scalable solution to meet the world's growing energy demands. For instance, a single space-based solar power satellite could theoretically power entire cities, drastically reducing reliance on fossil fuels. Governments and private entities are investing heavily in this technology, recognizing its potential to revolutionize how energy is produced and distributed globally. The mechanics. How does space-based solar power work? At its core, space-based solar power involves capturing sunlight in space, converting it into energy, and transmitting that energy to Earth for use. Large solar arrays are deployed in orbit to collect sunlight without interruption. These solar panels, often utilizing advanced lightweight materials, capture solar radiation and convert it into electricity. This electricity is then transformed into microwaves or laser beams, which can travel vast distances with minimal energy loss. These beams are directed toward massive ground-based receiving stations known as rectennas, short for rectifying antennas. Rectennas are designed to safely and efficiently convert the incoming energy back into electricity, which is then fed into the existing power grid for distribution. Recent advancements have pushed space-based solar power closer to reality. For instance, in January 2024, Caltech's Space Solar Power Demonstrator achieved a critical breakthrough by wirelessly transmitting energy in space. This milestone demonstrated the viability of wireless power transfer technology, a cornerstone of space-based solar power. Additionally, the increasing affordability of reusable rockets, such as those developed by SpaceX, has drastically reduced the cost of deploying satellites into orbit. These innovations have created an ecosystem where space-based solar power can thrive, making it a compelling solution to address the growing demand for clean, sustainable energy on a global scale. Recent milestones and demonstrations. The year 2024 has marked a turning point for space-based solar power, with several key advancements. One standout achievement was NASA's Advanced Composite Solar Sail System, which successfully deployed a solar sail in May 2024. This project highlighted the potential for lightweight, flexible solar arrays to play a crucial role in space energy systems. Despite encountering challenges such as a bent support arm that affected spacecraft orientation, the mission demonstrated the feasibility of large-scale solar technology in space. Advanced Composite Solar Sail System showcased the practicality of deploying and managing solar systems that could operate in the vacuum of space, setting a precedent for future space-based solar power missions. Such progress underlines the potential of innovative materials and designs to overcome logistical hurdles associated with space infrastructure. International collaborations and investments. The race for space-based solar power supremacy is no longer confined to individual nations. International partnerships are now at the forefront. A prime example is the October 2024 agreement between UK-based Space Solar and Iceland's Reykjavik Energy. With a £10 million investment from the UK government, this collaboration aims to place solar panels in space, 8,000 kilometers above the Earth, to harvest energy and transmit it to Iceland. This project reflects the growing global consensus on the need for innovative renewable energy solutions. Iceland, a leader in renewable energy utilization, is leveraging its infrastructure and expertise to integrate SBSP technology. Such collaborations underscore the strategic role of international investments in accelerating the commercialization of SBSP. By pooling resources and expertise, nations are not only driving technological advancements, but also creating a blueprint for global energy cooperation. The role of private enterprises. The space-based solar power sector has attracted significant attention from private enterprises, which are bringing innovation and capital to the table. A noteworthy entrant is Etherflux, a startup launched by Baiju Bhatt, co-founder of Robinhood. Etherflux plans to deploy a constellation of satellites in low Earth orbit to beam solar power to Earth using infrared lasers. The company's ambitious timeline includes its first test mission by 2026, with eventual plans to scale up operations for large-area energy distribution. Such ventures represent a shift in space-based solar power development, from government-led initiatives to private sector-driven innovations. Private companies are focusing on cost-effective technologies and niche applications, such as providing energy to remote or underserved regions. The involvement of private players also drives competition, spurring rapid advancements and reducing costs, much like the trajectory seen in the satellite internet and reusable rocket markets. Technological challenges and solutions. Transmission efficiency. Converting solar energy into microwaves or lasers and transmitting it over vast distances without significant energy loss requires cutting-edge technology. Current advancements in wireless power transmission are promising, but scaling them for space-based solar power remains a challenge. Safety concerns. High-frequency energy beams must be carefully managed to avoid harm to humans, animals, and the environment. Ensuring that the transmission process is safe involves rigorous testing and regulatory oversight. Cost of deployment. Launching large solar arrays into space is prohibitively expensive with current technology. However, the rise of reusable rockets like SpaceX's Starship and advancements in in-orbit manufacturing could significantly lower these costs in the near future. These challenges are being tackled by leading institutions and startups, with efforts focused on improving material efficiency, refining beam technology, and reducing launch expenses. Addressing these issues is critical to making space-based solar power a viable and sustainable energy solution. Environmental and economic implications. Space-based solar power represents a revolutionary step toward combating climate change by offering a renewable energy source that operates independently of Earth's limitations. Its continuous energy generation capability could drastically reduce reliance on fossil fuels, which are the largest contributors to greenhouse gas emissions. Beyond environmental benefits, the economic implications are equally transformative. The development and deployment of space-based solar power systems will create new industries, ranging from satellite manufacturing to rectenna construction and maintenance. For developing nations, space-based solar power offers a way to leapfrog traditional energy infrastructure and directly integrate into a renewable future. Additionally, reliable access to clean energy could spur economic growth, particularly in remote or energy-poor regions, unlocking opportunities for development and industrialization. The road ahead, future prospects. The next decade is poised to be transformative for space-based solar power, with countries like Japan, China, and the United States investing heavily in research and development. Operational space-based solar power systems could become a reality by the 2030s. These systems have the potential to revolutionize the global energy market by providing an inexhaustible and sustainable energy source. Further advancements in satellite technology, material science, and energy transmission will be critical in scaling space-based solar power from experimental to commercial stages. International agreements and standardizations will also play a crucial role in ensuring equitable access to this groundbreaking technology. By combining governmental support, private innovation, and global collaboration, space-based solar power could soon become a cornerstone of the global energy infrastructure. Thanks for joining us on Trendsetters. Don't forget to like, subscribe, and hit the bell so you won't miss any groundbreaking insights. Until next time, stay curious and keep exploring.